Question number 75 from June 2020 mathematical science paper. Let n be a positive integer and f be a non-empty proper subset of this sequence. So we have defined the inner product of xy, summation of k belongs to f, x k and y k, where x and y are two sequences which belongs to the real space, and we have to find which of the following statement is true, and we have given that t is equal to this x is an element of Rn space, provided that inner product of x with x is 0. So we have to find which of the following statements are true. So let us consider that f be a sequence 1 2 up to m, and phi is not equal to f, which is not a subset of the 1 2 up to n. T is already given, so from here, so let us consider this is equation 1. So we can write from equation 1 that x, which is an element of R to n space, the inner product can be written as x1 square plus x2 square plus up to xm square equal to 0, which is nothing but then the sequence will be 0 comma 0 xm plus 1, and the final element will be xm, right? So this will be, when we solve t, the sequence will look like this. Now check with one by one option. So the first option is, so we can write this. So suppose this infimum of x is an element of t, x plus y. So you have to find the, so it can be written as inner product x comma x f plus inner product of x y inner product of x y plus inner product of y x and inner product of y y. Okay, so infimum at where x belongs to this t is an element of t, the y inner product will be simply inner product of y comma y, okay, in this non-empty subset, right? Why? Because since inside f this x1 square plus x2 square plus x3 square up to this plus of xm square is equal to 0. So we can also infer from here that x1 equal to x2 up to equal to x10 is equal to 0. This will be inside f. So in our case the option 1 is correct, right? So let's check with the option 2. So option 1 is correct, but option 3 is incorrect. So in option 2 we have been given the supremum x element of t, x plus y, inner product of the x plus y f. So we have to find. Similarly we can write it over here that supremum of, if we inner product of x comma x x comma y, y comma x, y comma y. Okay, this is equal to the, if we find the supremum of x, okay, so the inner product of y with y, the supremum will be the same as inner product of y itself with y, and this also satisfies the equation 2, the option 2. So for this only the two options are, the option 1 and option 2, both are correct. So question number 76, let V be a non-zero vector. Define a linear transformation T where T is given by x minus 2x dot v, v dot v into v. So and x dot v denotes the standard inner product in the space R3. So which of the following statements are true? So we can write S equal to two x dot v by v dot v, v minus x, which is a reflection of x in the line along v, right? So t of x is equal to minus of sx, which is the negative of the reflection, and we know that reflection, this sx, is the distance preserving map. So is tx, both are the distance preserving map. So from the option you can see that option 4 is correct, right? Now let's check with the other options. So if we fix v equal to the R cube space 1 comma 0 0, then t of e1, if we consider it as one of the bases, so t of e1 will be t1 comma 0 it will be minus 2 comma 0 dot product of v. Okay, so it will be minus, so one of the te1 we got minus 1 comma 0 comma 0. Similarly t of e2 we can calculate. So what will be the t of e2? This t of e2 will be t0 comma 1 comma 0. So we can write in this manner. Similarly minus, okay, so we can write this, that 2 of 1 comma 0, similarly 2 of 1 comma is a dot product of, and here it will be e2, so it will be 0 1 comma 0. So what will be it? So 0 1 comma 0. So t of e2 is same as, now t of e3, t at 0 comma 1, so minus 2 of 0 comma 1 dot, so t of e3 will be 0 comma 1. So from here we can construct the matrix T. T is nothing but, so T of E1, the first row, minus 1 0 0, t of e2 0 1 0, t of e3 0 0 1, right? So eigenvalues are nothing but the diagonal entries, right? So eigenvalues will be here minus 1, 1 and 1. So what will be the trace? We can calculate the trace also. So trace of t will be 1, minus 1 plus 1 plus 1, it will be 1, and determinant of t is minus 1 multiplied by 1 multiplied by 1, so it will be minus 1. So let's check with the option. So option 4 is the correct one. The trace of t is plus 1. Yes, option 3 is also correct. And the determinant of t is minus 1. Option 2 is also correct. So option 2, 3, 4, these are the correct options.